Hello and welcome to this video. My name is Felipe Triana and my partner is Pedro Julian Sanchez. We are students from Santo Tomas University. I am studying environmental engineering and Pedro is studying mechanical engineering. Today we are going to talk about a green energy called wind turbine tower, explain how it works and why it is important to our degrees. To explain how these wind turbine towers work, first of all, we need to know what it is. The wind turbine is a clean energy that works with wind. It uses wind to create kinetic energy, and this energy is converted to electrical energy. The wind turbine tower has blades that use the airflow to move with different speeds. They have inside a generator that creates the electricity. The materials of making the blades are light materials because the length of this can be 88.4 meters and have to resist high speeds. Explain what a wind turbine tower is. My friend Pedro is going to talk about his historical background. Well, now I'm going to explain how a wind turbine tower works. A wind turbine tower has the function of harnessing the wind to generate electricity. This wind turbine tower works the opposite of a fan. They use wind to produce electricity in order to supply this clean and renewable electricity. In other words, a wind turbine uses the aerodynamic force from the rotor blades. The wind flows across the blade and the air pressure on the side of the blade decreases. The difference in a pressure created a lift and a drag. The lift is stronger than the drag and this causes the rotor to spin. Then this rotor is connected to a generator that speeds up the rotation. This relation of aerodynamic force to rotation of a generator creates electricity. After this explanation, we had a little video for you to understand better how this wind turbine tower works.
Hello, well, I'm going to talk about the history of the wind turbines. Although it is believed this technique is of the modern era. However, research found this is a technology antique. The dates back to 5 BC, which boats were used to move with the wind across the river Nile. In 200 BC, in China, they used wind to move clean water to different cities. Then in the Middle Age, in Germany, they used wind pumps to drain water into the river Rhine. Later in 900, in America, they used electric generators that moved with the wind, becoming what is now known as wind turbines. Most famous wind turbines: Centro de Energía Eólica Alta, Mupandal Wind Farm, Roscoe Wind Farm, Jaisalmer Wind Farm, Shepherd's Flat Wind Farm.
Last but not least, wind turbine has lots of advantages. One of them is that they has an unlimited resource, that is the wind. Another advantage is that it's one of the cleanest energies in the actuality. It also decreases the pollution caused by fossil fuels and is one of the cheapest electricity on the planet. Likewise, this green energy has a low operation cost and it has increased the job creation with lots of engineers. There are some important and interesting facts about these turbines. A large wind turbine can produce up to about 2 megawatts of electricity. The largest turbines can harness energy to power 600 UK homes. In 2020, wind turbines were the source of about 8.4% of total United States, and Colombia has a big wind turbine tower park project called Windpeshi in La Guajira to generate 200 megawatts. Well, we hope you like this video and learn about this green and renewable energy. Thank you for watching us.
How does a wind turbine work? You've probably seen a wind farm. But do you know how wind force is converted into electrical energy? We are going to show you how a wind turbine works. Each wind turbine has a wind vane at the top that indicates the wind direction. This allows the turbine to rotate on the tower and face the wind. The blades also rotate on their axis for maximum resistance. Wind force, that is, the kinetic energy contained in moving air currents, spins the blades. These are designed to fully capture its energy. They can be as long as 60 meters each and are made of very light and resistant materials for ease of movement. This is why they can produce energy even with very light winds, starting from about 11 kilometers per hour. With very strong winds, above 90 kilometers per hour, the blades are placed in the feathered position and the turbine stops spinning for safety reasons. The blades are attached to the wind turbine through the hub, which is coupled to the low-speed shaft. The low-speed shaft is given this name because it spins at the same speed of the blades, between 7 and 12 revolutions per minute. To produce electricity, it is necessary to increase the turning speed of the low-speed shaft. That is the mission of the gearbox, which raises the speed over 100 times and transfers it to the high-speed shaft. The high-speed shaft, that rotates at up to 1500 revolutions per minute, is connected to a generator. The generator converts the kinetic energy into electricity, a source of energy that is easier to transport and use. The electricity produced in the generator is conducted through the interior of the tower to the base. There, a transformer raises the voltage for transport inside the wind farm. From each turbine, alternating current is sent to the substation through underground cables. Here, the voltage is increased again to feed it into the power grid and transport it to end consumers. This is how we use the wind to light cities, feed industries, schools or hospitals, or operate our household appliances in a clean and sustainable way.
Parts of a wind turbine tower. The rotor. The rotor most suitable for producing electrical energy is the propeller type of the rotor. Converts wind energy into rotation under force is the engine. The nozzle. The nozzle houses all the essential components that are responsible for transforming the kinetic energy of the wind into a rotating generator that in turn generates electricity. The tower. The wind turbine tower supports the nozzle and rotor. In large wind turbines, towers can be made of steel, lattice, or concrete. Okay, the relationship between both engineering. We choose this because my partner Felipe studies environmental engineering and myself studies mechanical engineering. The relationship between these engineerings is because the wind turbine is for me as a mechanical engineering. I know how to make it, the process and the materials to choose, how to convert the energy, the wind to energy. And my partner Felipe, he knows how this can apply to the next energies, more clean energies, and the environmental impacts that this wind turbine has.